Hello, students. Again, another unofficial and unsupported C++ tutorial for those of you who are trying to get, who might have remembered less than you anticipated from your C++ classes. Um, yeah, today we're just going to do a super quick talk about handling files. Okay, so files usually have two components to their name. And I say usually, this is more of a convention than a requirement for file names. But typically, you have what's you refer to as the file name, which is the first part of this, followed by the file's extension. So a file name dot extension. So like this, say you had track 5 from a Wombats album. Track 5 from Wombats might be the name of the file. It's a music file, specifically an mp3.mp3. So name of the file dot extension. The name tells you sort of what topic-wise what the file is, while the extension tells you the kind of file, like the type of data that's stored there. Like mp3s are audio files, .docs or documents. This is things you've probably seen before. But it is possible, not recommended, but in most operating systems it's possible to have a file without an extension. So just the Wombats track 5, no dot anything. Now, your computer might not know what to actually do with that file. Some do. For instance, sometimes actually this was more common in Macs back longer ago than now. But file extensions weren't as tightly enforced. Instead, it would check the contents of the file to try to figure out what kind of data was stored there. So, on some machines, even if you didn't include the extension, it would still try to figure out, oh, this is an MP3 file, or this is a doc, or whatever. But the modern convention is file name, period, file extension. So name that's descriptive of the file's contents, period, extension, telling you the kind of data, how that data is stored in the file, essentially. Okay, so essentially there are two types of files. There are text files. These contain alphanumeric data. That means stuff that you can read. Your source files, like your .c's and your .cpps and your .h's and your .hpps, your .pys if you're working with Python, your HTML files for websites, and some documents that you work with are also alphanumeric sort of text files. Then there are binary files, numerically encoded data. So the programs that you compile, not your source code, when you compile your program, your .out files or your .exes, these are binary files. Most, not all, but most picture formats are binary encodings of picture data. Your audio and video files are typically binary as well. So why two types of files? Well, that's a good question. So text files are typically things that are human readable, easy for you and me and anybody to read. The problem is text encoding, matter of fact, anything that's made for a human to use is actually usually going to be pretty inefficient for computers to read. So these files usually end up being really big, which means it takes longer for a computer to read them in and process them. Binary files, these are typically not human readable, though I have met a couple human beings who could look at hex values and tell you what the text says. There are robots among us. Anyway, binary files are easier for a computer to read and write, and they're also much smaller, so they typically save space. But now here's the thing. The cake is a lie. In the end, both text files and binary files are all binary files. It's just the assumptions about how you read in the data is different. And no, so just take the dichotomy with a grain of salt. So in C, now remember, C is part of C++. So all the code you write in C will also function in C++. So you're going to see some of this stuff. There's a special file type or a special data type for dealing with files, and it's all caps files and an asterisk. Now you've seen that before. That means it's a pointer. Now this is what we refer to as the file handle. So a pointer to the location where your file data is stored. And use a function called fopen to open these guys. So fopen, first parameter, the path to the file, and then the mode you want to open it. The most common ones you're going to be using is R, W, and A. Read mode, write mode, and append mode. So reading from a file, writing a new file, and adding to the end of an existing file. So here's an example of a single line of code from C that will open a file for writing. So the W is writing. If you're hearing a lot of noise in the background, I've got a 3-year-old who's just really enjoying her Saturday, like a lot. So when you're done reading or writing from a file, just like opening it, you've got to close it. So there's a function called fclose, and you pass it the file handle that you opened. There's functions for reading and writing to the files. For instance, we looked at printf for printing things to the screen. You can just use fprintf, which works exactly the same way as printf, but instead of writing to the screen, it writes to a file. So yeah, more examples. You guys can try these on your own time. And remember, if you feel like, man, he's blowing past this pretty quick, this is a tutorial for you guys to just sort of get up to speed, because hypothetically, you guys have seen this in your previous class, so trying to help you remember the material. Okay, how about reading from a file? So we can print to a file with fprintf. Similarly, fscanf. So reading from the keyboard in C, you use scanf. Well, you can use fscanf, and the F in front of fscanf is for file, and the F in front of fprintf is for file as well. And so it works exactly the same way as printf, except instead of just the conversion specifiers and where you want to read it to, you also give it the file handle that you want to read from. And so here's a code example of working with fprintf and fscanf if you're interested in that. So what happens when you reach the end of the file? So files don't continue to infinity, they have an end. So let's say we wrote a program like this, and we were reading in something from numbers.txt. We could say, keep reading lines as long as we want. And, there could only be maybe 10 lines in this file, but we could still write our program to read 20, 30, 40, however many. And that would end up trying to read beyond the end of your file, which can make your program crash. So we need to find a way to make sure that we're not reading past the end of a file. And this is where we come into feoff. In class, we already sort of saw an example of eoff, E-O-F, end of file, when looking at your string streams. So feoff looks to see if the file pointer that you're referencing, if you're already at the end of the file pointer that you're referencing. So it returns 1 or true if you've hit the end of the file, otherwise it returns 0 or false. And so here's an example of using feoff to read to the end of a file. While not file, end of file, and the file handle we're looking at, print and read numbers. So how about doing this in C++? It's actually pretty similarly easy. Matter of fact, I would argue it's easier in C++. Okay, yeah, but you've got to add a new directive. In other words, a new include at the top of your file for this to work, and that is include fstream. Fstream stands for file stream. And so you've got to, the most common way you're going to be using this is you're going to make output file streams and input file streams. A common name for these is fout and fn for file in and file out. So those are kind of reminiscent of cin and cout. So this essentially makes the file handle that you're going to be using to write output to a file. Technically, it's a C++ output stream, which is technically different, but it's going to function effectively the same way as the file handles that you would see in like C or any other language. So you have to open it. So you've got to declare your output stream, and then you've got to open it. Notice that we don't have to specify read, write, or append here because you've made an output stream. It knows that you're writing out to a file. So just fout.open and the file name or the file path that you want to write to. If you want to append to it, then you've got to do something a little bit different. You do fout.open, the file name, and then ios : app for append. And so it says, we're going to set the input-output stream to append. Okay, so let's see, yeah, writing to a file looks just like how you would write to your screen. So it uses exactly the same format as you would use for using cout. But instead of writing this text to the screen, it gets written to a file instead, in the same way you would see it on your screen if you're writing output to your terminal. And don't forget, when you're done, you need to do fout.close, so closing the file that you're reading to. And you can end up with unexpected consequences if you don't do this. Sometimes if your program terminates, like your program exits and you didn't call fout.close, not all of your data might have actually been written to the file. Doing fout.close ensures that your file is all tidied up and everything's written to it when you're finished writing to it. Reading to a file, very, very similar. Instead of OF stream, it's IF stream, so input file stream. And a common name people use is FN because it's like CN, fn.open, and then the file name that you're wanting to open for reading. And just like with CN, you use that same sort of syntax there to read something in from your file. And just like with the string stream that we've looked at in class, it works very similarly to that. And though it's less risky not to close your input streams, you really, really should. It's good programming practice to always close a stream or a file handle whenever you open it. Okay, now this, works just like I'd expect for reading in an integer or a float or a double or a string. But if they're separated by white space, it's going to read it in as one integer, one double, one string. Sometimes you want to read in an entire line of text. And this is where we use getLine. GetLine, you've used it with CN to read stuff from your keyboard. You just replace CN with your input file stream, in this case FN, and it works exactly the same way. So it'll read us a whole line of text from your input file stream. It'll read up until it finds a new line character. So from wherever you are in your file stream up until it finds a new line, it'll take that data and store it in myString. Oh yeah, and of course you guys probably know this already, but don't forget to include your string directive at the top. So similarly to feoff, there's just member function in fn and fout called eoff, end of file, and it returns 1 or true when you're at the end of the file, 0 or false if you're not at the end of the file. And so here's some example code you guys can work through if you want to try experimenting with file input and output in C++. Okay, so that is our super quick try to remember these things from your previous class tutorial on C++ for the day. Hope you're all doing well, staying happy, healthy, and safe.